Hi, welcome to another episode of Dang, it's Math Time with Mrs. Morrow. In this episode, we're focusing on graphing these kinds of functions. Notice it's your standard form of a quadratic equation, and here you have your targets that you can pause and look at. All right, so we're going to start with substituting 4 in for x and a 3 for y. So in the end, no, this point here, 4, 3, does not satisfy this equation.
Pause the video and then try it. Seriously, try it. Okay, so I'm going to go ahead and walk you through this one. And what we're going to look for is the -1 is going to go right here. And that's going to be equal to -2 times x is going to be a 0 in a bit, plus 1/2 times x is going to become a 0 in just a bit, minus 1. So all I've done is substitute. And let me plug in the 0 in here. Well, what's anything times 0? Hopefully you remember that it is 0. So this is going to stay as it is. And on this side, 0 squared is 0 times -2. This will become a 0. This will become a 0. And we're just going to add the zeros together and this -1. Well, is this true? This zero's out with the -1 there on that side. So this is what it's going to look like. And it's true. So this one's a yes. It satisfies the equation. So this part 1 is looking for patterns, and try this on your own or with your partner, but since we're not in the classroom, you could possibly call someone and do this work with them. Hint, hint, wink, wink, now in the age of technology. Or do this by yourself. Either way, but I'm still going to help you.
Okay, so we're going to make a graph of this equation right here, and we'll do this one in just a bit. I'm going to start with making a table of values. Here they are. I'm going ahead and connecting the points on the right side. And the beautiful thing of parabolas is that they are symmetrical. So while I'm working on this, just let me show you. I'm going to flip this, and it should make a nice, there we go. It's not perfect, but you can see how it goes through each of the points that I had already preset. Now you try on your side. Pause the video at any time. Notice the values are different on this second equation, but yet A and B happen to be the same. So the question is, what do you notice about the x coordinate of the vertex? What happens to be the same, yes, you can see I use the ruler here, the vertex goes right through the axis of symmetry, so the x value or the x coordinate happens to be the same for both functions, even though their equations are different. The next question or task is asking us to find the x-intercept to this first graph. So you can see that the x-intercepts, we have 2 of them, are at 0, 0 and at 4, 0. So for this function, the zeros, the x's, the x-intercepts, they happen to be at 0 and at +4. But because it says x-intercepts, I'm going to put them in the form of an ordered pair. So there's that one. Factored out the 2x because that's the GCF of these 2 terms. And then I hope you guys remember from here we split them off into 2 equations. So we do the and you can see algebraically it matches the graph. And as you can see, the last part is just asking you to compare the x-coordinate of the vertex with the values that we found. And
Part 2 is on finding your x-intercepts. Good luck!
X is the greatest common factor. Separate into 2 equations and set it equal to 0. Solve for x. In this situation, x is equal to 0 for one of the x-intercepts, and the other x value for the x-intercept is going to be whatever the -b/2a happens to be. So this, when I substitute the 0 in for x, I'm going to get a 0 on all of this on the right side. So in this case, y is simply going to be a 0. So this is just verifying that the 2 x-intercepts that we had matches and is a solution kind of like we did on the warm-up. Okay, this appears to be tricky. When we square this fraction, it's going to turn into a positive because a negative times a negative will turn positive, and it will turn into a positive b squared over a squared. This second part over here of the terms, the second term, if we multiply these, I get b times a negative b, which is going to turn into a negative b squared over a. That means I can get rid of the plus sign because this negative sign is going to overpower. Cleaned it up a little bit. So notice this a value up here will get to cancel out with one of these down here. Don't forget chapter 6 rules, they still apply. And now I have b squared over a. And notice this is going to turn out to be a 0 as well. Interesting. Make connections.